All right, everyone. It's 11 o'clock. I will kick off, getting a prompt start, considering today's session's a little bit longer than our normal ones. Thank you for joining today's session, Spectralink Wi-Fi Solutions from Design to Employment, with our Channel Enablement Manager, Nathan Gibb. This session today is a real technical deep dive into Wi-Fi infrastructure, how you design it, setting yourself up for success from go to woe. Nathan not only is our channel enablement manager, but is also our wireless infrastructure guru within Wavelink. So this session today is going to be very technical. There'll be a couple of breaks throughout. What we do ask, though, instead of waiting for questions to be answered at the end, Nathan will actually be answering your questions as you go through to the length of the session. So put them in the chat box at any time you have them. Nathan will then address them as they come up. And then I'll come back on and regroup for a Q&A if anyone has anything at the end they wish to ask as well. With that being said, Nathan, I will hand over to you for the next 2 hours. Enjoy the sessions, guys.
Fantastic. Hello, everyone. Those that don't know me, as Craig said, I am Wavelink's Channel Enablement Manager and National Pre-Sales Engineer, predominantly focusing on Wi-Fi, Wi-Fi design, not so much implementation these days, but definitely Wi-Fi design across the board for Spectralink, and also Fortinet being our Wi-Fi vendor of choice at the moment as well, of course. So today should be a bit of fun in terms of what we're going to cover and run through. So today, it's actually a bit of a deep dive and to take a step back and to actually focus on some of the conversations that need to be had with our customers in terms of scoping an opportunity correctly. This itself does tie into some of the actual Spectralink training, and that will allow and enable our partners to actually potentially scope an opportunity better, again, from design to then implementation as well. So we're going to have a look at this Spectralink handsets to start with, a quick snapshot on the management servers. Then we will actually have a look at the management servers at the end, obviously with deployment side of things, scoping an opportunity with Spectralink's tools themselves, so the interoperability guides for phone systems, view certified wireless systems, so enterprise grade wireless and what that means and what should be scoped for those opportunities. Spectralink AIMS program as well. If you work with nurse call is a great example. You can actually integrate, obviously, most nurse call systems with Spectralink Wi-Fi, but if they don't have an integration available, you can also sign up to integrate and get the API and do the integration work as well. Another snapshot on our Wi-Fi fundamentals. Obviously, these are based around my years of experience, industry best practices, and then we're actually going to go for a bit of a deep dive into Ekahau and actual designing. And I'm going to show you guys some real examples of best practice design in terms of a data network and then a voice network, because it's very different. And also understanding that coverage is king. Coverage is key when it comes to designing a Wi-Fi network, because of course without coverage we can't connect to anything. So today should be pretty fun. We will stop a couple of times for a break, so I'll ask if we get a general consensus through the chat that everyone would like, you know, a 5-minute break to make a cup of tea or a coffee or whatever it is. We'll stop, but I'll aim to definitely stop at about the midway point at midday. We'll stop for 5 or 10 minutes as well. If anyone needs to pop off, obviously the session's being recorded as well, so that'll be fine. So again, welcome. As you can see, the isolation has allowed my beard to get even longer, going full length until we can get out of this stage 4 lockdown in Melbourne. But basically, again, quick snapshot and a refresher of the current handsets that are available when it comes to Spectralink Wi-Fi handsets. So again, the 8400 series, bread and butter for Spectralink for probably about 10 years now. These have been rolled out obviously across the board by many of our partners, very capable, standard type of phone, obviously not a smartphone, but can integrate with nurse call systems and other building integrations and other bits and pieces for messaging and alerting tones, safe functionality for man down, running, tilt, barcode scanner, etc. Again, this handset itself has been the workhorse of our fleet in terms of the Spectralink handsets for a long time, and still is sold where it's relevant to be sold as well. Again, you know, nurse call, aged care, retirement living, warehousing, manufacturing. This handset is still sold quite a lot when it's scoped for a Wi-Fi network itself. In terms of managing these handsets these days, of course, you can still go the traditional route, which is an XML provisioning server. Otherwise, the new functionality is also using Spectralink's CMS server, which is a configuration management server. So this is a nice GUI-based configuration platform that can be sold in conjunction with the 8400 itself. So on from there, obviously we've got now our Spectralink Versity handset as well. Give me a second, guys. I'm just going to kill the video because I've got audio loss. Spectralink Versity, so the 9000 series, so the 9500 handset, fully fledged enterprise-grade smartphone that is fully capable, fully integratable with any network, and again, being an unlocked Android smartphone, if there's not an application that is built for a business use or a use case that a customer might have, or you as a customer have, then just get an app developer to write an application for it. That in itself just makes the handsets so much more flexible and capable with integrating with any business system. Again, in terms of management of this device, itself, same thing as the 8400 with its CMS server. It has this Spectralink AMI Essentials SAM server. So the Spectralink Application Manager. Again, we'll go through a run through of the capabilities of the SAM server in terms of management of the handsets and its Spectralink applications at the end of the presentation as well. So again, tying into actual deployment and management of the handsets. But again, fully capable server to actually manage the devices. Now, scoping and opportunity. This is a really great baseline for any of our partners in terms of just, again, bringing it back to basics and understanding what needs to be done and or the tools that are actually available to you. Plenty of the time we get asked questions by our fantastic partners in terms of integrating with a Wi-Fi network. And now Spectralink themselves work closely with most major vendors in terms of enterprise-grade solutions with Wi-Fi. Spectralink work with those actual vendors themselves to have that vendor, so be it Fortinet, obviously we're a Fortinet distributor, Aruba, Cisco, Juniper, Ruckus, etc. As you can see here, it's just a snapshot of some of them. They work with that particular vendor. The vendor of the Wi-Fi equipment will then actually write a configuration guide. From that, they piece together the correct configuration to ensure seamless voice over Wi-Fi with a Spectralink handset. And that's how Spectralink themselves are able to offer such great audio quality in a voice over Wi-Fi solution. So the Views Certified Product Guide is one that can be looked at any time to validate whether or not the solution that you're scoping for a customer is actually going to be certified, and by certified also supported by our support team at Wavelink, but then the overarching support if we need to refer any logs or traces back to Spectralink themselves in the US as well. So we'll jump onto the website in a second and we'll just have a bit of a look around just to give you guys, again, just potentially a refresher, or some of you might have not have actually seen this side of Spectralink's capabilities, and will certainly give you a better viewpoint when trying to scope an opportunity potentially going forward. Again, simple question that we get regularly as well. Can it integrate with such and such a phone system or a call server? The Spectralink CSI, so the call server integrators, this is again another program that Spectralink themselves run with the particular vendors to actually create the configuration guides, again, so that the handsets themselves will be able to integrate with those call servers. So they have interoperability, which is fantastic as well. So again, I'll jump onto the website and we'll just have a bit of a look around there as well. Then they also have the AIMS program. AIMS, which is Application Integration and Management. So this in itself, once again, very capable, very useful, especially for our healthcare customers, warehousing, manufacturing, retail. you name it, there are ways to integrate. As you can see there, you know, healthcare, patient monitoring, EMR, and EHR. That should be, I've misspelled that, my apologies. Secure texting, nurse call, alarms and alerting, and then retail, obviously task management, inventory management, and push to talk capabilities. So these are ways that you can actually integrate the handsets to provide far better business functionality and capability with the Spectralink handsets themselves. So from there, and don't mind me, I'm just going to quickly pop into Spectralink's own website. So this is the support site for Spectralink themselves. So the support site itself, from here, obviously you've got Wi-Fi DECT if you're looking at DECT, but of course we're talking about Wi-Fi today, so we'll keep it on topic. From here you can see the full range of products that are capable to be used, but then also find configuration guides and integration guides. So if we have a look at the 8400s as a great example, we've got our call server interoperability guide here. If I click on that, it'll actually bring up the list of call servers that have actually been tested by Spectralink and the provider themselves. So again, you know, Avaya, Broadsoft, Cisco, Mitel, ShoreTel, NEC, etc. So there's a full list of certified call servers that are actually up on the support website, and ease and convenience of being able to go there anytime just to double check. And of course, we're more than happy to certainly give you the information as well. If you just come through to Wavelink and ask the question, we're always going to help you. But it's just always a great idea to potentially have this downloaded as a quick snapshot, so you can improve efficiencies on responding to your customer as well. For the Spectralink Versity, once again, interoperability, fully capable here as well. So not as many tested at the moment with the Spectralink Versity, but again, fully certified on Avaya, Cisco, DigiM and the Mitel systems at this point in time. In terms of the View certified guides, so again, the View certification is a voice interoperability for enterprise wireless. So we have plenty of instances where we have our partners who are scoping an opportunity for deploying voice over Wi-Fi for one of their customers, but they aren't actually scoping the wireless. The wireless has already been installed. And the wireless might be, say, you know, a Ubiquity system or a D-Link system or something along those lines. Something that, yes, those particular vendors have an enterprise-grade solution, but the solution that's been deployed isn't the enterprise grade and or it isn't certified. So Spectralink themselves, as I said, work directly with the Wi-Fi vendors. So again, your Cisco's, your Fortinets, your Arubas, to actually configure or create the configuration guide so that when you're deploying, if it's a Cisco network, you set up your wireless LAN controller or your Cisco Meraki cloud portal or your Fortinet wireless LAN controller. You set it up as per the configuration guide that Fortinet or Cisco Meraki has configured. So that way, when it's deployed on that specific network, you know with confidence that it should work as seamlessly as possible. There's plenty of times where we have had instances where the administrators on the network haven't actually deployed it as per the View certified guide, and of course then we will review it, go through with the fine-tooth comb and find that, you know, one or two features haven't been specifically turned on the voice subnet. Turn those on and generally that will fix the problem and get everything working. In terms of the View certified AP configurations, we have a full list here. So again, if we just scroll down, we get a really quick snapshot of just the capabilities with a lot of different vendors. So again, yeah, your Cisco's, your Arubas, Extreme, Fortinet, of course, Cisco Meraki, Brocade, Extreme, etc., etc. So there's a full detailed list here of approved devices and capabilities in terms of what can be deployed and what is actually certified as a View certified enterprise grade Wi-Fi solution. And again, that ties then back into certification as the Spectralink handsets can be used on that network, but then also more importantly, they are certified for support on that network. So Spectralink themselves, and of course Wavelink as the in-country vendor, our support team will jump on a call with you and try and do diagnostics to try and resolve any issues. If it is the root cause is the handset, or it might be the Wi-Fi network itself. So this list, again, is just a really good snapshot and potentially a great refresher for some, again, as I said, some people might not have seen this. This is generally where to go to find that really valid information in terms of scoping your opportunity and having those conversations with the customer, instead of it getting to a point of deployment and, oh, we're trying to deploy on a ubiquity network, and then coming to us and we go, well, unfortunately, that's not a certified solution. From there, the AIMS program, again, application integration and management solutions. So this is becoming a really key example, especially in terms of the new Versity handset. Obviously works and has worked well with the 8400 series as well, and some DECT integration also. But you can come here and actually have a look at the different products and capabilities that are at this point in time certified and integrated with this system as well. So fully capable. Again, if you had a service or a nurse call system or a fire alarm system or something like that that you wanted to actually integrate with Spectralink and use on their handsets, you can actually apply to Spectralink to get their API, so you can actually write the code to integrate an application on a specific handset that you want to use it with as well. So Spectralink themselves as a company are always willing and open to working with new vendors and new providers so that they can integrate and of course use their best of breed wireless handsets on their network. So again, very, very useful, very, very cool. All right, let me jump back to the Prezzo. Cool. Wi-Fi fundamentals. For those that have had my other courses, whether it be online or face-to-face, some of this will be another good refresher. I have added some more information in here as well. But yeah, it's basically going to be, again, that snapshot of Wi-Fi best practices, and then we're going to jump into some design as well. So again, where are we now? Obviously, Wi-Fi 6, 802.11.ax is the current standard. Wi-Fi 6 is really now included ramping up the capabilities of Wi-Fi across the board, even from a small network to a large network, be it a small office to a large university campus. Wi-Fi 6 is going to just create so much more capability for the wireless network in terms of density and speed capabilities as more and more devices are connected to Wi-Fi. Again, evolution of Wi-Fi. Back in 1997, when we had data rates of 2 megabits per second, we now have the theoretical maximum of 9.6 gigabits per second. To actually achieve that speed is, not really that doable, but it's a great theoretical max, again, in a closed environment. So I'm not going to go through all of this in detail because that's quite a large spreadsheet. But again, a bit of a snapshot in Wi-Fi itself. Obviously, two streams or two spectrums that it works on, 2.4 gigahertz. At only three non-overlapping channels, 1, 6, and 11, 22 megahertz wide. Great signal penetration because the sine wave itself is longer, and fantastic for a distance link, but not great for high density. Hasn't always worked on high density, it's better for coverage. In terms of Wi-Fi 6 itself, the 802.11ax, we're going to see a revamp of 2.4 gigahertz, especially for IoT, as we can split the channels up and use the sub-carriers within a 22 or 20 megahertz wide channel itself. So that's going to actually see a revamp of the capabilities of 2.4 gigahertz itself. 5 gigahertz, obviously not to be confused with 5G. Obviously works at a different frequency and a different transmission rate. Obviously this is for enterprise and home use. But capabilities, obviously, and the advancements with 5 gigahertz itself. In terms of design philosophy, it's about density, not coverage. So you generally aim for more access points to facilitate more concurrent clients, which can then also handle higher speeds as well. Obviously capable of 802.11a and AC and AX bands as well. 25 non-overlapping channels if you're using the Uni 2 extended. Depending on your regulatory domain in your country, will depend on the specific channels that you can use at a given time and at a given place, of course. So it'll be a case of checking with your regulatory domain in the country that you're in. Obviously, we're in Australia, so most of them can be used. There are a couple that can't. Generally, for the most part, free of congestion, as long as you're doing your channel planning correctly. Congestion-free Wi-Fi for the most part, because in terms of 2.4 to 5 gigahertz, there's not a lot of other products that work, as in non-Wi-Fi specific products that work on 5 gigahertz. Obviously, one of the major ones is a great example for 2.4 gigahertz is a microwave. A microwave oven emits at 2.4 gigahertz as well, and can cause interference to your Wi-Fi. So not great if you're trying to cook popcorn while streaming a movie. Throughput itself, far greater capabilities in terms of throughput and higher speed capabilities. Again, with 802.11ax, we're going to be able to see far greater throughput for more connected and concurrent clients themselves, which again will take into account channel bonding, and channel bonding itself should be used sparingly or only where majorly applicable as well. Again, another just quick snapshot of the slight differences. 2.4 gig to 5 gig, there's just a simple example of the sine wave itself. So interference obviously a lot higher on 2.4, greater range though, but bandwidth on 5 gigahertz itself is far, far greater. My general rule, and something that I've stuck to over many, many years, and it's served me well, is 50 users per radio on an AP. So if you're looking at a dual 5 gigahertz radio, you could have up to 100 concurrent clients as well, as long as they're not all trying to stream 4K video simultaneously. But otherwise, the network should work very efficiently itself. So bandwidth management as well, another great example of designing your network correctly, and again taking into account having enough clients or having enough capacity for clients. So obviously, if you've got clients roaming around your network and one specific area, so a great example of an area that might be overutilized is always theaters or lecture theaters in universities or schools, high schools, etc. So obviously designing for the capacity of, let's say, 200 devices, and it might just be laptops, it might be tablets, it might be then phones on top of that as well. So you might go from having 50 users, then all of a sudden you add another 150 clients, and if you've only got one access point in there, the bandwidth division and capability is going to fall over. So again, making sure that you have enough bandwidth management and capacity for those clients to actually share the Wi-Fi itself. Fundamentals, obviously, the basic service area is the signal that the clients can hear. The basic service set is what is being broadcast, and obviously what the clients connect to, as well as the service set identifier, which is the SSID that floats in the air. AP handoff, again, this is really critical, not just for voice over Wi-Fi, but of course voice over Wi-Fi is far more volatile, so it needs a far better capability to hand off for the clients who roam between access points. Obviously, when it comes to sticky clients, that would be the case of one client itself staying attached to one access point and not roaming to the best available access point as it's further down the network itself. And unfortunately, when it comes to designing network, you can design the best network in the world, but if you've got a sticky client, it's the client itself that chooses when to actually disassociate and reassociate from one AP to another. So that's where the sticky client comes into it. And unfortunately, it's the client itself. So it could even be the chipset of, let's say it's a phone or a tablet or something that's roaming around the network. If it doesn't want to actually roam, then yeah, you've got issues. So there are ways to get around that by trimming, lower data rates and other bits and pieces. But again, ensuring that you've got correct handoff and cellular coverage for the access points is one of the major keys to designing a good Wi-Fi network and providing a good experience for the connected clients. Obviously, transmissions themselves, the further away from the source, the weaker the signal, the weaker the throughput for the clients as well. So the RF signal itself obviously starts to deteriorate. Wi-Fi capabilities well, they're going to start increasing obviously with the advent of 802.11ax. Wave 2 capabilities that came through with AC certainly gave us again some faster throughput capabilities and better capabilities with multi-user MIMO as well. So being able to send spatial streams to multiple clients simultaneously instead of one client hogging the airspace while it transmitted, and then all other clients waiting for that clear to send before they get their chance to actually transmit as well. This snapshot is a great example of a good way to articulate to a customer why they don't see the crazy speeds that they see on a box and go, I bought these access points and it said 3.4 gigabit, 46 gigabit per second. Why can't I achieve that throughput? And of course, throughput itself and bandwidth are very different, so it's always an interesting conversation. But this in itself is a very simple snapshot of the requirements for clients and Wi-Fi systems themselves to actually achieve higher data rates. So this is a very simple one. I've got another couple of slides coming up because I thought I'd take it into a deeper dive and show people just how crazy it can get with the bandwidth division with different modulation and other bits and pieces. But again, this is a really nice simple snapshot for everyone to understand. If you have a 3x3 capable access point, so 3x3 MIMO capable AP, pushing out its data, and then you have a client device, so whether that's a laptop, a tablet, obviously a phone, whether it's your Spectralink Versity handset, which is fully capable as well. If it's connected and 3x3 as well, over 20 megahertz wide channel bonding, the maximum that we would hope to see in theory, again, with no other interference from any other network, would be up to 216 megabits per second. Then if we do channel bonding, so that's joining two channels together to effectively give us a double the amount of bandwidth, then we could potentially see up to 450. As we can see here, to hit those theoretical maximums, we're going to need to do 160 megahertz wide channel bonding. So that's taking 8 channels on the 5 gigahertz spectrum. Needs to be a 4x4 MIMO radio, and client has to be, they both have to be capable of 4x4 multi-user MIMO, and just to hit that theoretical max of 3.46 gigabit per second, which again is not really attainable. You could do it if you're in a Faraday cage, so fully enclosed, sitting very close to the access point, no outside electromagnetic interference. You might be able to get that for one client. So when it comes to designing an actual usable and stable Wi-Fi network for a customer, I generally, well, for starters, never usually go past 20 meg wide. So I keep all channels available. So that way my channel planning is far more flexible and far more capable. But if they do need a little bit more speed, then yes, 40 meg wide channel bonding is possibly the better option. Going up to 80 and 160 meg wide, you just lose out on the capabilities of channel reuse. And if you have a very large site with a lot of access points, a high density solution, the ability for channel reuse and the need for channel reuse is very high. So you still need that capability. So just hitting potential theoretical maximums for throughput isn't as good sometimes, or a lot of the time, as getting a stable connection that's still going to provide a lot of clients with a good throughput and capability and better channel reuse, so you can actually roll your network out and have that designed a lot better. In terms of RF math itself, obviously having a look at the actual different terminologies here as well. We've got dBm to decibel to milliwatt itself, and power levels also. So those that do Wi-Fi design and play around with it all the time, some of this might not be new to you, but some it might be as well. So as you can see here, as we go down the sliding scale, we're only transmitting at very, very low power. And whenever we're looking at actual design itself, we're actually designing in the negative. So it's a good threshold for a voice over Wi-Fi solution is between neg 30, so negative 30 dBm, and neg 67 at a maximum as well. So the transmission rates themselves are very, very low. Again, some data rates here. So this is looking at older technology and older types of modulation itself. So OFDM and CCK for 802.11b. So B is obviously quite old, and generally if you can avoid using B radio or the B frequencies itself, definitely turn that off. But again, it just shows you the capabilities, but also the actual dBm or the decibels to milliwatt that you need to actually achieve those speeds. So again, I'm showing you this to give people a better understanding of what's actually required to hit the possible speeds that a customer might need. So if we see here, if we were, back in the days when we were using 802.11g and we needed to hit a maximum threshold of negative 67 for a voice over Wi-Fi solution, well then the theoretical max data rate is going to be 6 megabits per second. Obviously, this is getting to the fringe of the Wi-Fi access point signal. The closer we get to it, the better signal that we get, we can obviously start to see those data rates increase. Again, going through 802.11a with OFDM for its modulation as well, and 802.11n. Obviously, N was superseded by AC, and AC is being superseded and we'll be working in conjunction with AX, but again, just gives you a good snapshot of the speeds that you should really be seeing when you're on the threshold of that good signal for voice over Wi-Fi. So again, if you're getting to the fringes of your network, you're still only going to get around 6.5 megabits per second. But for a voice call itself, that still should be fine, because the voice packets themselves, although they need good QoS on the network, are quite light in the actual packet size itself. And of course, getting closer to your transmission, you're going to see lower connected rate, which is great, and higher speeds as well. And then we just get a little bit crazier. Again, this is looking at different types of modulation for 802.11ac. This is where we start to get into 64 QAM, so quadrature amplitude modulation, how many spatial streams that we're using, etc. So this is when you can start to actually see your higher data rates. So again, what starts as a nice simple slide to explain things in simple terms, starts to get a little bit crazier when you start digging into the proper values themselves. So one of the things I was touching on before, correct channel planning. Again, if you're looking at a network and you're trying to roll out 160 megahertz wide channel bonding, again, that will be using eight channels across the 5 gigahertz spectrum. If you just look at this diagram itself, well, you're going to run out of channels very, very quickly. Because again, of course, these beautiful little circles is not how Wi-Fi works. It does not work to the fringe of a beautiful little circle. It spreads and spreads and spreads. So ensuring that you have enough channels for channel reuse and proper planning is always key and crucial to designing a really solid Wi-Fi network. A great example over here again of 802.11 and 2.4 gigahertz and its complete lack of capability in terms of its channel reuse as well. And of course, if you had all of these deployed, all of those radios on the same channel will be able to hear each other and will be causing some co-channel interference with each other as well, because of just how far the signal can spread at its lowest data rates. One of my greatest analogies I love to use, which really gets this message across, is an access point is the center of a donut. I thought I'd go one better for today, obviously being that we're doing this as a live demo. I can't just hold up a AP. So this is a three-dimensional example of exactly what a Wi-Fi signal will look like when it's being pushed out from a omnidirectional antenna, or omnidirectional access point itself. Well, access point with omnidirectional antennas built into it. So again, the center of a donut analogy always works. And again, this really ties back to the design philosophy itself and installation, where access points should always be mounted on a ceiling, so horizontally mounted, not vertically mounted, unless the vendor itself specifies that that particular access point can be vertically mounted, so on a wall. They should always generally be as central as possible in the middle of a room, obviously not in a corner, because they're going to have their signal absorbed and reflected straight away, as centrally as possible wherever they can be mounted, and mounted vertically, just to ensure that the signal spread is going everywhere you want it to. All right, Attitude 11AX or Wi-Fi 6. So the future of Wi-Fi. What do we got coming? So some of the major or key points for Wi-Fi 6: OFDMA, orthogonal frequency division multiple access. It's a really good one to say 5 times in a row. BSS Coloring, target wait time enhancements, higher data rates of 1024 QoM, so the quadrature amplitude modulation, and its constellation chart as well. So that's in terms of figuring out whether signal is coming in phase or out of phase, etc. And then uplink multi-user MIMO, which is also going to be very, very cool. That in itself is getting as close, or basically, to being able to send and receive simultaneously. So what's Attitude 11AX going to bring us? As we can see, speed and efficiency is going to be one of the major benefits to Wi-Fi 6 or Attitude 11AX. It's focusing on being far more efficient, which is fantastic. Management itself, management frames and physical overheads still restrict and consume variables like airtime. So it's actually going to make that far more efficient as well. Density, again, 802.11ac did a great job of allowing for higher density solutions and better solutions when it came to high density. And this is just going to be compounded and improved once again with AX and the capabilities that it has. So the physical changes, again, so the higher data rate capability of 1024 QoM, up to 10 gigabit per second data rate. That's of course using 160 meg wide channel bonding with an 8x8 radio and client, not that any exist at the moment, clients more so than access points. That's for both 2.4 and 5 gigahertz, which is fantastic. BSS coloring, so the BSS, they now have a color bit assigned to their header. So that in itself is going to be very interesting to see that in use itself. I'd love to test, but I don't have an AX client. The clients themselves can be identified by their BSS color, which is great. It'll allow for reuse of the spectrum and transmissions unless the same color is actually detected. So again, allowing for better airtime for the clients to actually transmit and receive simultaneously. Then management itself, so OFDMA. So this is going to allow for the channels themselves to be broken up into sub-carriers. So for far more clients can transmit simultaneously. As it says there, simultaneous transmissions of lots of users, up to 9 in a 20 megahertz wide channel, basically. If you do channel bonding, well, then you can have more clients on top of that again. So OFDMA, what does it do? Again, as I said, breaks a given channel into sub-carriers, and that itself will transmit and receive independently. The access point controls how much of the band is actually used and who it actually assigns the use to. So traditionally, we've had one client that will take up a full 20 megahertz wide channel, and it'll send and then receive. And then of course, all other clients have to wait for their clear to send message when in their list of available time, and then take up that full 20 megahertz wide channel. What this is going to give Wi-Fi the capability of is assigning enough bandwidth to the clients based on their need, not just overall transmission. So if they only need a small subset of the available megahertz or the available space in a 20 meg wide channel transmission, then that will give the ability to divide up and spread the signal or the capability, the bandwidth, to the client itself. So it's going to be very, very cool. This is a simple example again of how it has been and what is going to happen going forward. So again, standard users all getting their own chunk, and now we're going to have the capability of multiple users actually sharing the bandwidth to have it subdivided and allow for more transmissions simultaneously. So it's going to be very, very cool. Looking forward to seeing it in use going forward. BSS coloring, again, so this is effectively putting an extra packet in the transmission to tell the client and other neighboring access points on the same channel what color they are. So that way when the client itself is transmitting, especially when you take Wi-Fi into consideration, if you've got a roaming client like your Spectralink Versity handset or your 8400 series handset, they're of course constantly walking on the go, able to move around the network freely. So the chance of being in the fringe of two access points on the same channel can be fairly high. So if it's assigned a color, it's effectively saying, oh no, I'm transmitting to access point A because I'm the black color, whereas the other AP has its yellow coloring. So it has a differentiation between where this actual signal and requests are coming from and where they're destined to. So again, it's going to improve efficiency on the network itself. This technology, Fortinet themselves have their virtual cell technology. This is very similar to that capability. And as a Fortinet distributor, we're looking forward to seeing the capabilities of this as, of course, virtual cell itself is going away. So again, just a bit of a snapshot of sort of visual representation of how it works. So again, just looking at those APs, this is on 2.4 gigahertz is a great example. Previous slide was on 5 gigahertz. So we're looking at our channel 6 here. Those clients, again, on the fringes. Again, Wi-Fi doesn't work in beautiful little circles, unfortunately. If we could stop the signal from going that efficiently, it would be lovely, but of course we can't. So these APs will always be able to hear each other on the lowest data rates. So again, the clients themselves that are connected to it will get that coloring, so that way the access point knows what when the client transmits that it's supposed to be transmitting to that particular access point, instead of this here is a great example being on the fringe of 2. And does this client transmit to AP A or B? Well, it knows because it's got its BSS coloring attached, which is fantastic. Target wait time. This is actually, again, this is going to be great, especially in terms of fleet management for handsets, for your Spectralink Versities, for your Spectralink 8400s. We've had times where, again, the Wi-Fi itself hasn't been rolled out correctly as per the View certified guide, and the target wait time or the sleep timers haven't been set up efficiently enough. So the handset's batteries run low. Target wait time is going to improve the efficiency for clients themselves. So clients themselves will stay awake until they actually receive a transmission or have a request to send a transmission itself. So again, this technology itself is going to be another really key, simple feature that's been brought in to improve efficiency on the network. So again, QAM and Wi-Fi signal strength itself, as we sort of touched on the previous slides, the capabilities and the requirements to hit those higher speeds. So again, this is a real good snapshot of sometimes, yes, hitting your high speeds would be great if you're wanting to download the world's largest file as quickly as possible. But in terms of an actual real world scenario, you may not deploy a network that's using 1024 QAM on 802.11ax, because you're going to need to do 160 megahertz wide channel bonding. If your network is fully capable of that and you don't need too much channel reuse, go for it. But again, to achieve the theoretical maximum speeds, you need a signal of negative 45 dBm. So again, it's that balancing act of providing a good network where you can see really great speeds at higher dBm compared to lower as well. If we look at the actual constellation chart for 1024 QAM, this is the old 16 QAM. So again, the actual transmissions themselves come into this constellation chart and it'll hit somewhere around one of the dots. And that then tells the receiver whether or not it's in phase, out of phase, etc. There's a lot of science and physics that go back into it. So that's a 16 QAM constellation. 1024 is going to have a 25% data rate increase, and it'll look like that. So again, the maths and physics that are going into it to actually allow for the constellation chart to work efficiently, to know where the data bit is going and what particular part in that quadrant. Yeah, very funky, very cool stuff. So uplink multi-user MIMO. Again, this is definitely one of the coolest parts. It's going to allow simultaneous, basically as close to simultaneous transmissions to and from as possible. So we're literally getting very close to full duplex over Wi-Fi. So something that I'm quite excited about, again, definitely to test and play with. Now again, what's the usefulness of 802.11ax? How can it benefit my network or my customer's network? Well, it comes down to efficiency and it comes down to high density. So great example, schools, universities, hospitals, aged care, you name it these days, basically. IoT is the use case for 802.11ax or Wi-Fi 6. We have so much stuff now that's being put onto the Wi-Fi, and Wi-Fi as a median, obviously being a shared median, we need far greater density and capability. So this in itself is one of the major beneficiaries of 802.11ax or Wi-Fi 6. We're going to be able to see far more connected clients and concurrent clients be able to connect. They may not obviously be transmitting all simultaneously, but again, when you think of IoT and you think of the amount of things that you have on your person now that can connect over Wi-Fi, yeah, it's going to improve efficiencies for that. And again, your lecture theatres, large capacity or high density solutions are going to benefit from 802.11ax dramatically. So that's going to be very, very cool, especially in terms of planning and design going forward as well. All right, what's the time? 10:02. I'll just quickly do a check of the chat box. No questions, no chats. Cool, sweet. We'll stop in about 10 minutes, guys. So quality of service. Again, voice over Wi-Fi. Voice itself has always been a volatile medium. Ensuring that your switch ports themselves have enough QoS on them to allow for a good voice over IP solution was always critical. Wi-Fi itself, again, being a shared medium, not just providing connectivity for your laptop or a tablet or something like that, but obviously putting voice on becomes quite volatile and needs good quality of service. So, to be considered, enterprise grade, obviously the audio quality needs to be comparable to a desk phone or a wired handset. Otherwise, clients aren't going to use them. Has to have really great tolerance, obviously, for latency, jitter, packet drops, and poor voice quality, etc. And the implementation of good quality QoS, as you can see there, will definitely impact either call and voice quality, but then the battery life and capacity of the handsets as well. So it is key to be configuring properly. So prioritization of the packets. Again, this just comes down to standard design and network planning as well. making sure the switches that you're connecting the access points to are up to date, up to speed. The backbone itself is fast enough, and of course the configuration of the switch ports is allowing for the right QoS as well. Time delivery, extending the battery life is definitely one of the capabilities as well. Providing handsets opportunity to make AP handoff without missing packets. If you've ever actually done any testing or some troubleshooting when it comes to voice over Wi-Fi, if you're trying to deploy voice over Wi-Fi on a data network, if you're listening and doing test calls, you can literally hear the access point, so the client, so the handset itself, hand off from AP to AP once it finally disassociates and reassociates. And again, that comes down to planning for a voice network, not a data network. With a voice network, obviously you've got more access points providing better coverage for secondary signal coverage and primary rate coverage as well. But that in itself is what can allow and what should allow for that seamless roaming. So if you're on a call, you don't want to hear a sort of click over when you change APs, and you certainly don't want that break in transmission while you're speaking down the phone as well. And of course, bandwidth management as well, avoiding oversubscription and ensuring that someone sitting at work might be on YouTube watching a 4K video, they don't get preference over your voice call as well. So again, some of the just key points, even just around the 8400, obviously it's DSCP values of 46 and 40 as a default from the vendor itself, and then standard planning as well. So your packet prioritization with WMM, time delivery with WMM power save, WMM admission control for bandwidth management, and again, supported vendors. Well, we went over the view certified list, and we can recap that as well. And I'll be sending a list of that stuff out anyway. But again, we've seen the certified vendors that are supported in terms of the QoS. So your WMM extends the legacy of CSMA CA, so carrier sense multiple access collision avoidance. If anyone didn't know that acronym, again, another fun one. So it's a mechanism that gives the devices the same priority based on the best effort. So again, just ensuring that that voice packet has priority over everything else. Your power save mode, again, to ensure that the handset's batteries aren't burning very quickly. Generally, when it comes to the quality of Spectralink's batteries, they will last a full shift if they've been used throughout the day, making calls, receiving calls, getting nurse call alarms, etc. The handsets are designed to last a full shift because healthcare itself is a key vertical for Spectralink and its handsets. So ensuring that your power save mode is configured correctly will certainly go a long way to help battery efficiency as well. WMM access control, so optional for the access category, mandatory bit set for the voice and or video access categories, and then mandatory itself. If the AP does not advise the ACM bit set for both voice and video, then the phone will not attempt to associate with the AP. So again, that one's pretty critical to make sure it's set up correctly, because if your handsets won't associate to the AP because it's not configured, well, the network's not going to work very well as well. Again, just another snapshot of some of the actual transmissions and acknowledgements, etc. So just key QoS variables for the power options and power save. So again, guys, this is just a brief snapshot into some of the key topics that are actually within Spectralink's online training certification for the 8400 and the Versity handsets themselves. So access control. So WMM stipulates different fixed and random wait times for 4 prioritization categories. So those categories, your voice, video, best effort, and then background as well. And that in itself comes down to most designs when it comes to QoS on your network, always giving voice the highest priority. Obviously video is always secondary because it comes, like obviously if you're doing a video call, that needs good prioritization. Best effort and then background is definitely not used by your phone, but that would be sending emails and general web browsing, etc. So your admission control itself, new technology that defines industry specifications on emerging AP support. So it's not mandatory, the AP, but it's highly recommended as well. All right, guys, let's stop there before I jump into any Wi-Fi design. We will, feel free to, I've got 11:56 now. So if we come back at 10 past, that should give everyone enough time to stretch your legs, make a cup of tea, cup of coffee, and we'll kick off with Wi-Fi design at 10 past 12. All right, guys and girls, we'll get started shortly. It's 5 past. I know everyone probably wants to get on with the day as well, so we'll start in a couple of minutes. The next part itself is going to be more around, again, design best practices themselves. I'm going to jump into Ekahau Site Survey and just show you some of the nuances with Ekahau, its capabilities, and how Wavelink itself as a distributor and as a company goes about designing Wi-Fi to make sure that it is designed to industry best practice, but also voice over Wi-Fi best practices as well, and why sometimes you can design good Wi-Fi and bad Wi-Fi very, very easily. So we'll kick off in probably another minute or so. Again, feel free to post any questions in the chat or the question box itself. More than happy to take any questions while we're waiting to kick back off. Okay. All righty, it's 12:07. Let's get cracking. So, again, Wavelink is a distributor. One of the value adds that we have for our partners is the ability to design Wi-Fi networks, both passive site surveying as well as active on-site surveying to validate a design or to troubleshoot a potential issue as well. But one of the conversations I always love to have, especially with customers, so I've done a lot of design for schools, especially schools, hospitals, aged care, conferencing centres, etc. But one of the general conversations that I love to have isn't to do with their Wi-Fi, because at the end of the day, the Wi-Fi itself is only as good as the network it's connecting to. So every time I have a conversation, it always starts with this here. You know, how good is their actual network infrastructure? How good is their switching? How old is their switching? How old are their switches? Are they, 1 gig switch ports? Are they old 10 by 100s? Let's hope not, of course. What's the backbone like for each switch, especially when it comes to schools? Because unfortunately, obviously with schooling, sometimes they can be underfunded. Many times they can be underfunded. So when it gets to the fringes of the school itself, they might just have a 1 gig backbone. But if you've got 2 or 3 access points on a switch that's then providing coverage for maybe 70 plus students, that 1 gig backbone might not be sufficient as well. So again, making sure that the actual uplinks from your access layer to your distribution layer to the core and then out your internet connection are actually sufficient and fully capable of supporting a good Wi-Fi network. So I always discuss around, what firewalls are hopefully a FortiGate. Obviously, we're a Fortinet distributor. But in terms of that, how fast is their internet connection as well? Is it going to be fast enough for the amount of clients that are going to be joining the network and their requirements? So how much data will each client use? What types of devices are those clients going to be using? And then what applications and programs and video streaming, etc., are going to be needed to be pushed over that Wi-Fi network? when you sit down and have that constructive conversation and really ascertain the data around the amount of connected clients, the types of connected clients, so phones, laptops, tablets, Spectralink smartphones, Spectralink 8400 series phones, etc., you can start to paint a picture of just what might be needed for the network itself, and then start scoping the right solution as well. But that can also lead into an even better conversation around a more holistic approach to a solution as well. You might have just been there to try and sell or try have a conversation with a customer. Never try and sell anything because no one will buy it. To have a conversation with them and actually build a relationship, and you'll have a better opportunity. But in terms of that itself, well, you're there to just have a conversation around Spectralink Wi-Fi phones, and then you ask the questions around how old is the switching, how old is their next generation firewall and router, etc. How old is their Wi-Fi equipment? Is there a refresh capable for all three of those components as well? So again, start a bigger conversation than potentially just the Spectralink handsets themselves. Building layout and floor plans. This is really key in terms of understanding Wi-Fi and how the signal may or may not spread through a customer's network. And again, this really comes down to the nuts and bolts of designing good Wi-Fi. Plenty of times that I get sent a hand-drawn map or something that was done in Microsoft Paint, or I don't even know, but those particular types of in quotation marks, I'll call it maps or floor plans, aren't really usable. And the reason that they're not is because we need something to scale. Everything when it comes to Wi-Fi design and planning comes down to something scalable, because we need to know just how the signal of an access point is actually going to spread throughout the network and spread throughout the environment in the building that the Wi-Fi is actually being installed into. And to that level, you then need to understand the components and the structural materials that are actually within the buildings themselves. So again, concrete, brick, double brick, your Besser bricks, your reinforced concrete, or metal, wood, metal frames with plaster over them, fire retardant materials in retirement living or aged care facilities, etc. Cladding materials, how absorbent or reflective are those materials? Glass, is it double glazed, triple glazed? Those themselves will stop a 4G or 5G signal coming in, so you can sure as hell bet it's going to stop your Wi-Fi as well. So really understanding all of those components can then tie back into designing Wi-Fi as efficiently as possible itself. Obviously, understanding some of the key characteristics of Wi-Fi and how it actually works. I've got a snapshot here, and this is just some of the Wi-Fi behaviors, probably some of the more readily seen behaviors themselves. So again, your wave propagation, that's how the actual signal moves away from the AP. So easy analogy for that is just ripples in a pond. Again, that donut analogy as well, and that 3D image of how the signal spreads. Attenuation and loss, again, as the ripples move, the further they get away, the smaller the ripples get. Obviously, I've got there in brackets as well, not always bad, because sometimes you want, or when you're designing for more high density solution, you may not want a high signal, because of course the access points will start to shout over each other. Free path loss, obviously the loss of the signal, again, just purely as the waves broaden. Your reflection, so again, reflective surfaces themselves, so glass, metal, anything with a reflective surface, the signal itself can reflect off and go in weird ways. Absorption, fairly standard, thick brick walls, reinforced concrete, double brick, Besser brick, trees. Good Lord, do trees love to kill Wi-Fi? They love to absorb and scatter because of the trees and the branches and the leaves, all that sort of stuff. So again, scattering there as well. But then we also have diffraction and loss and other bits and pieces as well. So what I'm going to do now is something that I haven't actually done in the level of depth that I'm about to do. So there should be a bit of fun, hopefully, for those that don't use Ekahau or haven't used Ekahau. It's going to give you a bit of a snapshot into planning with Wi-Fi in Ekahau itself. So I'll just turn that off. So I said a very simple statement earlier around Wi-Fi. And there's one key thing that should never be forgotten when it comes to Wi-Fi design, and Wi-Fi planning, and that is coverage is king. Coverage is key. Without coverage, you do not have Wi-Fi. So this is a very simple design, very simple example of a site. So this is a scalable site. This itself, I've pulled this actually from the Ekahau certification course. I'm an Ekahau certified designer. And this itself is a small clinic. And as we can see, I've turned off the signal strength for the APs. With Ekahau itself, you go to the level of actually drawing on all of your walls. Each wall itself has a different attenuation value, so it'll drop the signal of a simulated access point. So we can change the different attenuation value by turning those walls into brick walls or concrete or an elevator shaft, etc., etc. So again, key planning and accurate planning is what comes down to designing a good network. But I'd made the point around coverage being key here. So what I'm going to do, I'm going to select a few APs. I'm going to turn these off. That wasn't right. I'm going to disable those APs. As we can see here, we can still get a pretty good connection for, let's call it almost half of the network, half of the site. So if we then position that AP here, okay, yeah, cool. We've still got, you know, not a bad connection, but obviously everything in these fringes is outside of the bounds of a good connection. So if we're having a look at that in itself, we can adjust. This is set to a voice network. So if we went up to -70, as we can see, we only get a little bit more of a fringe. And again, this, I'm showing you this as well for another reason, is to, you can design Wi-Fi very well in Ekahau, but if you're trying to be dodgy, you can also make it look a hell of a lot better than it should. So there are tricky ways about planning Wi-Fi and making sure that the person that's actually designing the Wi-Fi for you is doing it properly as well. So, but basically the key I was making here is, again, making sure that we have enough coverage.
There you go, we're back on.
Awesome. All right, I'm back. Sorry, everyone. My audio decided to just delightfully cut out, but that's okay. Let's continue. So the point I'm trying to make here, and Craig just said one of the last points was that I was showing you what the coverage of one access point is like. Obviously, turning the power up of an access point just to facilitate better coverage, which is what I've done with these two APs, isn't the way to go about designing good Wi-Fi. Because again, if I drop those to 25 milliwatt, it will of course reduce the signal. If I increase that back to 100, then they're basically running at almost full power, which at the end of the day is not great for Wi-Fi access points. It's not great for anything to be running at full power all the time. So one of the major considerations here though is, okay, well, what happens if one AP goes down? So if we just disable that AP, well then again, half of our site doesn't have coverage. So again, this is coming back to my very simple point around coverage is key, and coverage is king when it comes to Wi-Fi planning and design, and making sure that you have adequate coverage. So I'm just going to go back a few steps, and then I'm just going to show you another quick example of under-scoping a design and not getting the right detail to understand what is actually within the buildings. So if we were scoping this and the map itself doesn't show us much detail in terms of the walls, and let me just grab those walls and I'll delete those walls. As we can see, they just look like standard plaster walls. I'll press Control-Z and I'll put those back in. What I can do though, and again, if these walls themselves were double brick and far thicker than what we first had anticipated, if I go and change the wall itself, oh, sorry, let me We go to the drywall. I'm going to change the attenuation value of that. I'm going to set it to 15 dB. So that itself is going to absorb the wall very, very well. As we can see, the signal itself of the access points is stopped dramatically. So what was potentially a good network, because we thought it was just a plaster wall, then becomes a very bad network. And this is the primary coverage as well. If we have a look at secondary coverage, which is what we need for roaming and handoff for a voice over Wi-Fi solution, well, we don't really have anything. So again, just a really great example of what can happen when Wi-Fi itself is not designed properly. So that's the secondary coverage. So I've just set the walls back to 3 dB, which is the standard variable in Ekahau itself. I usually set them a little bit higher, at around 4 to 4.5, to give myself a bit more of a real world understanding, and take into consideration potentially, you know, some furniture that might be behind the walls, some furniture, other things like, you know, en suites. So dealing with tiles, mirrors, plumbing, electrical, all of those things will impact the signal as well. So if we have a look at the signal strength again, it's looking great now. So that's a snapshot of a very simplistic site. Now, if I go to a bit more of an advanced design, this in itself is a great example of a multi-storage site that has a lot more access points and has more coverage requirements as well. So again, we might have a lot more staff in here, a lot more requirement for faster connectivity, but then also, if we're looking at our channel interference, we have to take into consideration the channel planning as well. So at the moment, I've only got a small area of channel interference, and that's because I've got 2 radios that can hear each other. Now, if you have a look at that, we have the access points on channel 64, but they're on different floors. So again, this is taking and giving you a simple snapshot and understanding that the signal itself doesn't just spread across the floor, it will go above and below the floors as well. So if I go back up to floor 3, this AP is the one in question. So if I edit that access point, change its channel, let's just go 140, let's take a stab in the dark and hope that fixes it. Oh, no, it caused another issue for another AP below that's still on channel 140. So again, what I'm trying to show you here in a very simple snapshot is that channel planning itself and channel and actual AP placement design has potential to impact your network if you don't take the consideration to actually understand how the signal is going to spread as well. Now, this is only on 20 megahertz wide channel bonding as well. So if I edit that, and channel width is still 20, let's go there. If I go to our auto planning tool here and I go 80 meg wide, let's watch and see what happens with that. So we're going to potentially have faster throughput, but channel interference, let's see how good that's looking now. Hey, look at that. Really, really bad channel interference. So you've got a lot of access points shouting over each other because they can hear each other on the spectrum. So if I mouse over that area there's a lot of access points that are all utilizing the same channels that are bonded together, and that is going to cause impact onto the wireless network itself. Again, if we have a look at the signal strength, yeah, signal strength is great, but again, how good is the channel, how much is that channel interference going to impact your network and cause issues as well? So that, again, is just a really nice, simple snapshot of designing. And again, if we took that into consideration with changing the attenuation values of the walls, so if I change that again, and we set that to, let's say 10, which is a standard variable for a brick wall, as we can see, if all of the interior walls were brick, and we didn't actually have that information when we're doing our design, well, our design itself is going to fall over, and that would be installed. And then the customer themselves are going to be pretty annoyed because they don't have the coverage as per the passive design itself. We would then need to go through and systematically add more access points to fill the coverage holes. As you can see here, I'm just winging this on the fly just to try and facilitate that better coverage. Obviously not trying to get the APs too close to each other because we don't want them too close, and that's not ideal, those 3 or 4 in such close succession there. AP over here, again, this is just a nice simple snapshot of just how understanding the scope and requirement of the network can impact the design phase and then obviously implementation as well, because we can't design correctly, or if it's not designed correctly, then the implementation is going to be majorly impacted, and especially the customer's experience as well. And that's what we really try and focus on, ensuring that our partners are armed with the most accurate information as possible, as long as we get the most accurate information, so we can design the best network possibly as well.
Nathan, another quick question here from Liam.
Yep.
Liam Heaver, he said, I guess it just kind of speaks to what you were just saying then, about how accurate do you recommend trying to get floor plan measurements should be? We should be trying to get as accurate as humanly possible, I'm assuming.
Oh, definitely, mate. Yeah, and great question. Thanks, Liam. In terms of, so and that's kind of why I made this sort of tongue-in-cheek comment earlier. I've had requests for designs come through, and literally they've been hand-drawn maps or done in paint or something like that. Nothing scalable. So the worst designs itself will always come out of the worst supplied floor plans or maps or something along those lines. So you need something that's scalable. So in terms of scale, if you're at a complete loss, then generally I try and look for a doorway that looks as close. And again, this isn't the greatest example, but look for a door that looks like a standard doorway and measure it to 1 meter. If you've got a full scale length of the building, so you can find the building on Google Maps is a great example, and then get the measurement from end to end. Measuring it at that distance will give you a far more accurate indication of the actual full size site itself. And obviously, if this doorway, again, if we go to this particular doorway, if that was say 1.2 meters over a small site, the variance isn't going to be great, but over a large site, the variance, of course, if you're missing 200 mil, it starts to impact the signal spread of how it's represented in Ekahau as well. So trying to attain the most accurate floor plans from the customer is highly advised. And of course, it produces the best results as well. So generally, and a lot of the times, if I've used Google Map images, if I don't have a full scale on, if it's an architectural design PDF or something like that, if it doesn't have a scale that I can use, and I use outdoor measurements on Google Maps, you could then a lot of the time come in and do a quick use your measurement tool here and go, okay, let's just double check how accurate that was and get it. And that itself, that's 900 mil. So the scaling on this site was actually pretty damn good. So again, just a bit of a real world example, and great question, so thank you very much. Right, one more quick comparison. And now this is a comparative design that I did recently for one of our partners. So I hope they don't mind me showing it, but it was a really great example of the difference between a voice and a data network. This is basically an aged care or retirement living facility. As you can see, there's a lot of walls, a lot of interior walls. And this is what should be done generally. This isn't the cleanest, but this is a great example of a voice over Wi-Fi solution. If I look at the secondary signal coverage, which again allows for accurate roaming, it's not 100% accurate, but it's a hell of a lot better than the data network that was originally scoped in itself. So if I have a look at this, this is the data network. If I have a look at the secondary signal coverage here, it's basically got no coverage overlap. And the customer themselves, they're using Spectralink handsets, and they've had issues with roaming and call drops. And this is basically why there's no secondary signal coverage. Secondary signal coverage with Wi-Fi offers up the next available AP in case the access point goes down, but then also for roaming, so that the clients themselves know where the next AP is that they're potentially going to need to roam to if they actually were walking around the network. So again, good snapshot of basically, you know, this was a retrofit to facilitate more APs inside the existing design. It's not perfect, but it was basically a great example of how the difference between a data network and then a proper voice over Wi-Fi network as well. So one of the areas which is a great example is this area down here, where there was only 2 access points scoped, where none of those rooms there, that's a secondary signal coverage, but even primary rate coverage, they don't actually have any coverage. Again, you can go to the level of, you know, what I like to call fudging the figures and go, oh, we'll just turn the power up the APs. But again, you're just stressing the access points out, and even that itself hasn't actually pushed that. It's at 100 milliwatt. So that's fairly high in its power output. It's still not actually facilitating coverage in those areas and in those rooms. So if a nurse or a carer went into this room with its voice over Wi-Fi handset, you're probably going to have call dropout. Even in this transition area here where there's a nurse's station, that doesn't have any coverage itself because of the walls and the attenuation values. Again, that is not what we're looking for when it comes to Wi-Fi design. So designing Wi-Fi properly with the most accurate understanding of the site and the walls is the best way to go about it. All right, enough about Wi-Fi design for now. Let me jump on to, let me plug in, give me a second, guys. Let me plug into so management of the devices. If I can type my password. Oh my goodness. I've got dumb fingers right now, I apologize. I've got dumb fingers and a cranky 5-month-old out in the other room. All right, management platforms. So once you've scoped, designed, implemented the world's best Wi-Fi, I've possibly designed it for you because, you know, that's all I do. Management of the handsets. Management itself, again, has come a long way from the traditional, especially with the 8400 series, that is, from your traditional provisioning server, which is basically a server on the network hosting an XML file that the handsets will call back into and request any updates if there has been any. The new age version of that is the Spectralink CMS server, so the configuration management server. This in itself is a great console to see real-time statistics and data about the network at any given time, about the handsets and how they're performing, but then also configuration and management of the handsets as well. So as a quick snapshot, if the phone was provisioned and came on to the CMS server, it's always put into the pending area. From here, you can actually select the phones. Obviously, if I had any in there, I've already approved them. They then go into approved lists. If we go to the device list itself, we can then actually get a snapshot and understanding of actually the handsets themselves. If you've got 200 handsets and they're on there, well, there'd be a ginormous list, of course. From here, we can get some really great data on the handsets. And some of the key statistics that you can see, just like this now, are your battery levels and your battery statistics. If you've got a handset that's plugged in and is charging, it will actually show up as charging as well. You can see your extension number, your device serial, etc., whether it's active or inactive. So I've got 2 of my handsets turned on right now, so I can make a call. last heartbeat, which is every minute on the 8400s, IP address, RSSI value. My little access point is sitting right next to it, so it's got a great RSSI. Again, battery cycles, etc. So great snapshot for an administrator on a network, or if we're helping you troubleshoot as well, we can log in and actually see real-time data. From here, if we wanted to configure an individual handset, well, we can actually go in and do everything on a nice GUI-based format. So for those that aren't familiar with XML configuration and management of the handsets, the CMS server streamlines that efficiency of being able to see everything in a very nice functional graphical user interface, which is great. Obviously, Skype for Business integration is capable as well. So this handset itself is set up with 1501 as its extension. So I've literally got two phones here. I've got a couple of 8400s and a Versity. So I can just basically make test calls and actually set up and play with stuff live here as well. So other key features and capabilities as well. Your personal alarms, so your tilt and running sensitivity, warning alarms, all that sort of stuff can be configured, and DureOS capabilities can be configured and managed within the CMS server itself. Just give me a second, guys. Sorry, guys, I just had to politely ask my beautiful 4-year-old to stop screaming at the top of her lungs. So again, management and capabilities of your devices. So now management itself, it comes in 3 different levels with CMS and also the AMI Essential SAM server, which is for the Versity handsets. We've got, at this level, we're doing device level configuration. So if you've got individual levels of configuration that are needed on one handset, or you wanted to do logging as a great example on a particular handset, if you're doing some troubleshooting and testing, you can log specifically on one handset. You've then got your configuration tab here, which is your enterprise level. So any changes actually made within this area are pushed out to your entire enterprise. So when I actually do my face-to-face training, it's a bit of fun because I try and articulate this particular point to people attending, and I then patiently wait for someone to do their configuration that's supposed to be device level on the enterprise level, and watch all the other class attendees wonder why their handset isn't working because they all have the same extension number. So it's basically gives you different levels of configuration for what would be pushed out on a traditional site configuration file, then group configuration file, and then a user configuration file as well. So a great example of a site-wide configuration might be the SIP server IP address and port. So I've got that configured at the enterprise level. Then any handset that hits and is managed by the CMS server is going to get that specific IP address for its for the SIP server itself. So again, very useful. You can send custom configurations to it as well. Anything that's not actually manageable through CMS, you can actually still send custom XML coding through to as well. Batch configuration, if you had a large site and you wanted to import all of your extension numbers and tie them to specific phones, if they were being used like that, they weren't using handset sharing, then you can upload a batch file, which is just a CSV file with your MAC addresses, extension numbers, SIP credentials, etc. So you've got that capability as well. RMA functionality. This one's very, very useful, especially if there was a fault with the handset and it needed to be swapped out. You can actually, if you've got a like-for-like handset, select the device itself and select that device, select your target device as long as it's the same handset, then send it through and it'll actually copy over the configuration file. So again, very, very useful. Group configuration. As you can see, I've got a little test site here. We can set up another group. So we'll just go test 2. We then select the devices that might be in that group. And then we can then come down and actually do configuration on that group. So group configuration, again, very, very useful. Whoop, let's change the configuration. Very useful, especially for functionality like the personal alarm or safe functionality that's built in with the 8400s, or push to talk is another great example. So we can actually configure. So Great example, nurses at a hospital might have the safe functionality turned on for their tilt alarm, run sensitivity, duress events, etc. But janitors may not. So you can actually set up different groups for the different organizational groups within the business and ensure that they have the functionality and capability that they need for their actual work requirement. So that's for the 8400. Obviously, just a quick snapshot of the capabilities with CMS. Very, very functional, very, very cool. So that is how you would deploy and manage those handsets easily. In terms of the Spectralink Versity, now it's a bit more of a complex story with the Versity itself, obviously tying in with an MDM like our SOTI Mobi control that we also distribute as well. But in terms of general handset management, it ties back in with Spectralink's Application Manager or SAM server, which is under the OMNI Essentials suite of products as well. So out of the box, configures just like your CMS server. It's a Linux VM that you can spin up on any server. I run mine on a small NUC PC. I've got both of them running off the same NUC, and you'll see it looks very, very similar. Heartbeat for the smartphones is 15 minutes as a minimum because they basically that's their default threshold. I've got 3 handsets that I've got turned on at the moment. Same thing again. The configuration and management is just the same. You can do your device level configuration, group level or enterprise level. And whenever you're configuring within OMNI SAM server, you're actually got the capabilities of configuring the Spectralink applications that are installed on the handset. Obviously, depending on the customer's use case and their requirement, they may not specifically use these applications like the native BizPhone application. They might use another third party. But if they are using these particular applications, you can come here and do that custom configuration. So again, great example, same SIP server, of course, it's on the same network. So, and again, this just shows the capabilities of fleet management. Some people you might want a Spectralink Versity smartphone for, others you might just want the 8400. But of course, they can be tied into the same network, which is completely fine, completely compatible with each other. Setting up your extension number again, so I could pick up and dial 1508. Let me give that a crack. Give me a second. 1508. Should. Yeah, there we go. Cool. Answer a phone and talk to myself. And away you go. So again, nice and simple in terms of its configuration and a very simplistic, easy to follow server itself. So again, all of these applications themselves, so your OMNI agent, your barcode scanning functionality, if you've got a barcode scanning Versity handset, your battery life configuration, enable battery monitoring, etc. The BizPhone, if you're using your native BizPhone app, configuration of the buttons on the handset itself, device settings, etc. All of these applications can be installed onto the Versity and can be managed through the SAM server itself. So your system updater as well is how you would update the firmware on the handset as well. This in itself, again, this is a great example of an enterprise configuration. If we come over to the list of menus on the side here, if I hit applications, looks exactly the same, but of course this is now the enterprise level configuration where we were on the device level before. So anything that we want to be an enterprise level configuration, we can do specifically through here. Once again, we've got the capability of setting up our groups. You know, I've got a couple in here at the moment, no devices assigned, but certainly has the capabilities again to set up your devices within organizational groups and have different features and functionalities assigned to them, which is fantastic. Once again, batch configuration can be set up to push out configuration very quickly as well. Your licensing, just like the CMS server as well, its licensing is in here. Out of the box, 10 licenses for the handsets, so that's how I use them for my training and demoing. Obviously, if you've got a fleet of 100 Versities, you would need 100 licenses, which is fine. Copying the configuration, which is one of the newer features that has just come in, very much like the RMA process, but being able to copy your configuration as well. So again, deployment and management of the handsets, both 8400 with CMS, and then the Versity handset with the OMNI Essentials SAM server allows for streamline efficiency for your deployments as well. And that is probably enough of me talking. Any questions?
Cool. So we'll open up to questions now. If anyone has any more questions you'd like to ask before we wrap up for today, just put them in the questions or the chat box. Nathan, is there anything else that you wanted to quickly cover off or anything like that?
No, that's really it, guys. Like, again, I mean, feel free to reach out to myself or any of the team at Wavelink in terms of scoping or designing an opportunity. Again, the stuff that I covered off today is a precursor to the Spectralink online course and certification course if you're not certified. And it just gives you a good snapshot and possibly a good way of just thinking around the right questions to ask that you may not be already in terms of that integration with an enterprise grade Wi-Fi solution, making sure that the call server that you're integrating with is certified as well. And again, of course, the main focus, designing proper Wi-Fi and ensuring that the Spectralink wireless handsets will work as efficiently as possible.
Cool. We do have a question for Liam just before we wrap up.
Yep.
So back on the wireless design, is it common to mix and match AP models for higher throughput or power APs in central areas versus lower cost APs in the periphery?
Great question, Liam. Look, whenever I'm designing, again, I will always try and ascertain those high density areas so I can get a better understanding of the requirement. So in terms of that, yes, you might look at putting in, say, a great example is some of the new tri-radio APs with the Wi-Fi 6 variants. So you can set up dual 5 gigahertz, but then other parts, and those APs themselves are a 4x4 MIMO radio. Then you might still look at facilitating a 2x2 or a 3x3 radio from the same vendor, of course, to facilitate areas that don't need that high density as well. Generally, whenever I'm designing, and especially a lot of the time it's for aged care, retirement living hospitals with Wavelink and the opportunities that our partners come across, a lot of the times I will have a generic access point that I will use for the entire design. Unless it gets to something like an outdoor AP, then I'll obviously facilitate something as well. Generally, a mix of APs in terms of their capabilities shouldn't be too much of an issue, but it would always depend on the vendor as well. So, yeah, you can definitely design with multiple APs as long as they are, facilitating the requirement for the area that they're being put into. Like schools is a great example. I've designed networks for schools with more access points or a higher spec or higher capable AP in conference rooms and auditoriums where they need that greater density access, and then classrooms with a standard 3x3 radio with less throughput capability.
Cool. Awesome. Thank you for that. If there is no other questions, thank you very much for everyone attending today. I have no doubt your brains are a little bit mushy by the end of it, so go get some lunch. We'll be sending around a follow-up email tomorrow with the recording and Nathan's details as well. If you do have any questions following today's event, you can always reach out to him directly or through the marketing team or through your respective channel managers. Thank you, Nathan, for taking the time to present today. It's been really, really, really great to have this session done. Thank you everyone for attending, and we look forward to seeing you at an event soon.
Cheers, guys. Have a great day.
Thanks everyone. Take care. Bye.